Hi and welcome to Lab 2. This is Jeff Crow, and today we're looking at the motion of a falling object where the velocity is not constant because there's a non-zero net force acting. The object will fall under gravity, but we'll also be interested in any effect of any drag through the air might have on the motion. So we'll look at two cases, first with gravity only and then with gravity and a drag force acting. This is our object that we're going to study. It's a Havaianas sandal. I chose it because it's a flat object, and so I'd expect there to be some drag that I could measure as it fell through the air. So the setup was we dropped the sandal from 1.54 meters. We took video at 30 frames per second. The sandal weighs 208 grams, and we analysed the motion in tracker to gather data about the object falling. And then we modelled the two scenarios in VPython to compare those models with what we observed. And for this experiment we chose the plus y direction axis to be in the plus y in the upwards direction. So the free body diagram for the two cases, in the first model it's only gravity acting, and as we'd expect with a non-zero net force, the body will exhibit an acceleration which will increase the velocity until it hits the ground. In the second model, as the velocity increases, we would expect to see the drag force increasing, and that will counteract the force of gravity as we go on. So after a short time the drag force will be quite small, but later on during the motion the drag force will increase because the velocities also increase, and we'd expect it to counteract the force of gravity, and we should see the object falling with a constant velocity. So the physical model is where the drag force, we're postulating that it's proportional to the square of the velocity, and we'll be looking for a drag force constant minus b, which will be something particular to the object under study, and so we'll be trying to determine that through experiment. The weight of the force is just minus mg, and the net force is the addition of those, on the system is the addition of those two forces, the weight plus the drag. And we'll calculate the velocity using the momentum principle. So here we see our object falling. And if we go to tracker, we can analyse that motion. And already we can see that after an initial acceleration, the velocity seems to be becoming constant. So if we transfer that data into Excel and graph it, and then go to Python and model the motion, setting the drag force constant to 0, so in our net force calculation we only include the force due to gravity, and run that, and then have a look at that compared to the observed motion, we can see a very close fit early on, but as we go on during the motion, the model seems to predict a faster velocity than we actually observed. So if we go back to VPython and include the drag force by setting this coefficient to something other than 0, and we determine this value by trial and error, trying to get a constant that came up with the final velocity of the object, which is minus 1.0932 meters per second, and that came out at a b of 0.08. So after running this and then transferring the data to Excel and comparing it with the observed motion, we get a very close fit, so which indicates that the model is very closely predicting what we're seeing in the observation. So finally, looking at the results and looking at all three, the observed motion with the model prediction under gravity only and the model prediction with gravity and the drag force, we see that the two forces acting together provides a very good prediction of the model, and in fact the model seems to be showing a constant velocity after a short time, which indicates that the Havaianas are probably reaching a terminal velocity. One final thing that we did was look at the situation where we might have an initial velocity greater than 0, and I modelled it using -5 meters per second, and we can see that that very quickly just ends up with a constant velocity all the way through the motion, which seems to indicate that an initial velocity will overwhelm the drag force if large enough. So, thanks for watching.